I wanted to actually review the problems that we did in class yesterday. And so, as I mentioned in class, I needed to change a couple things on this particular assignment simply because I just couldn't print it right. So, I've labeled the energies in the bar graph appropriately. This is supposed to be E dissipated. They didn't give us a mass, so I gave us a mass of 2 kilograms and a spring constant of 100 newtons per meter. So initially the cart is moving, so it has a speed. It has no height. It has no spring energy at this point because there's no spring compressed yet. So I just want to note that there is no spring energy. And we also note that there's no dissipated energy yet because nothing's happened. Now at the end here, it does come to a stop. There is no height still. And as far as spring energy goes, well, we do now have this spring compressed. So I'll just put a little check mark there to indicate that we have a compressed spring. So we actually use these facts to draw our energy bar graph. So initially, V is bigger than 0. That means we definitely have kinetic energy. The fact that H equals 0 means we have no gravity energy. And the fact that we have no spring in the problem yet means we have no elastic. Now, once the spring is compressed, we come to rest, so we have no kinetic. That's why I write V equals 0. You don't have to write this little V equals 0 things in your bar graphs. I'm doing it just to kind of label why I have the kinetic as 0. Same with the gravity. We have no height energy, so our gravitational energy is 0. And finally, we have elastic energy, which is where all the energy ends up getting stored. We have no dissipated because we weren't given any friction in the problem. So now, based on this bar graph, we can actually set up our equation by simply copying the bar graph energies and setting them equal to one another. What we should do next is go to our formula sheet to write down the right formulas for each type of energy. So we have 1/2 kx, we have 1/2 mv squared for the kinetic energy, equaling the spring energy of 1/2 kx squared. In other words, all this kinetic energy gets converted into spring energy. Now I'm going to do something a little bit unusual. I can cancel the 1/2 on both sides. And I'm going to divide both sides by the letter k to isolate x squared. And now I'm going to take the square root of both sides. And so for me to get the compression length, I need to take the square root of this whole quantity. So a little bit of algebra there for you. mv squared over k. So when I put in my numbers, that's going to be the square root of m, which is 2, v squared, which is 5 squared, which is 25, divided by k, which is 100 newtons per meter. And when we actually work that out, we're going to end up getting 0.71 meters of compression. So that's the first problem. And in our next video, I'm going to take a look at the bullet block problem that we actually did in class as well.